Good morning, good afternoon, good evening. Thanks for joining this instance of the Antrea community meeting. Today is Tuesday, November the 7th or the 6th if you are in the United States. And for today, we have a presentation about a proposal for node network policy that will be given by Chan. And I don't have anything else on the agenda for today, so it will be just this and then open discussion. And that's all from me. And I will hand it over to Chan for the presentation.
Thank you, Salvatore. Let me share my screen. Yeah. In this meeting, I'm going to present a proposal supporting node network policy in Antrea on Linux platform. And first, let's share some background about this proposal. About 1 year ago, we received several requests about whether Antrea could control node traffic through network policies using the same posture as Kubernetes network policy or Antrea network policy. And if you know external node feature, you would know that they are actually very similar. External node in Antrea is to control the node traffic, which are not a Kubernetes node, but they also use the same network policy API, Antrea network policy API to apply these policies to nodes network. And because of both features are very similar, and so in a previous meeting, I proposed to leverage the latest implementation for the former as well. However, we also know that it's not very steady in the external nodes implementation, because to realize network policy for node traffic, we had to attach the host's network interface to OS bridge and move all last 3 functions of the uplink device to a virtual device of OS. This will cause some problem when DHCP is used to get the IP lease of the uplink device. And here are 2 issues which have been opened for external node feature. Both of them are issues encountered on cloud, and when the operating system used some network manager to manage the network device, it will have some conflict after the device is moved, is attached to OS bridge, and another virtual device takes over its networking function. So when we want to have this ability for Antrea to control Kubernetes node traffic through network policies, we also look at other options. In this meeting, I will also talk about what investigation we have done and why we finally choose one of them. Yeah. So the motivation of this proposal is to, one is to have the same ability as some other CNIs to restrict traffic to or from Kubernetes nodes. And this ability could also work for host network ports because they share the same network namespace with Kubernetes node. There are at least 2 other CNIs already have this feature, as far as I know. And the second motivation is to find a better data plane implementation for external node feature, because currently there are some platforms issues and some data plane conflict which we are not able to resolve in a generic way, and yeah, and it's potentially hard to maintain compatibility with various operating systems as well. So let's talk about solutions we have investigated for this feature. The first is the one we have used in external node feature. The essential is we attach the uplink network device to open switch bridge, then the traffic will go over the will pass the bridge, and we get a chance to enforce some their policies. The problem of this solution is because if on some platforms, if the IP address of the uplink is retrieved by DHCP protocol and or is managed by some network managers, this could cause some problem because we have to move this IP from this device to this device, and the network manager could then find that the IP is missing on this device and assign another IP to it and cause some conflict. And it has another defect that only the network device that has been attached to the bridge could be enforced in their policy. And for other devices like this one, if the node has more than one network device, it will not managed by the applied network policy will have no effect on this on traffic passing through this device. There is another solution that is used by something else. Is essentially leverage the TCE-BPF hook, so that the agent could program to inject some programs into kernel and filter the traffic according to the their policies. It also has its own problem. First is advantage is it has full control over this node traffic, because you can literally program have any programs as you want to classify the packet and to take action after classifying the traffic. One problem I can think of is that it also is not very friendly to support multiple devices as well, because the eBPF hook is per device. So if we want to apply the same traffic, the same network policies to all network devices of a node, it will need to be repeatedly doing the same thing for all devices. And another problem is even with this ability to program kernel, the mechanism to classify packets based on priority and to support stateful firewall, it's not a travel walk. So this is basically a work will be an effort starting from scratch, and compared with other solutions, it doesn't just mean using eBPF could get better performance. In this scenario, I will talk about what is the reason later. And Jianjun and I also discussed the third the third solution is that we still leverage open switch, the existing work, to enforce the null policy. However, to make the traffic pass the bridge without attaching the uplink device, so we don't have the problem of DHCP and conflict with network manager. We leverage TCP/PF to redirect the traffic only. As you can see from the picture, the uplink device is still there, and we don't touch them. However, we install a TCP/PF program in the ingress hook of this device, and we redirect its incoming traffic to a virtual network interface, which has already been attached to an OS bridge. There will be a one-one mapping, and we redirect the traffic to its egress direction so that the traffic will be sent to open switch. Then in open switch bridge, we will process traffic like we process the traffic for ports. And if the null policies drop the packets, it will be dropped there and will not send it back to the device. And if the null policy says it should be allowed, we will send the traffic back to the ingress of this virtual device. Then we have another TCP/PF hook in the ingress of this virtual device, and we will redirect the traffic to the uplink device again. And here, when we process the packet another time in the uplink device ingress, we will send it to the user space following the original networking stack it should go with. And there are some problems need to be resolved. The first is that there is potentially a loop when we do the redirection. For example, when the packet is sent back to the ingress of ETH0 the second time, if we don't have any special handling, it will be redirected again and cause a loop, infinite loop. So here we need to take care of this situation, and we can fix it by marking the traffic that has been redirected once, like using the packet mark. And for example, we mark the first bit of the mark to 1, and meaning it has been processed. And when the TCP/PF of the uplink device met a packet with this mark, we know that it has been already processed, and we will not redirect it again, and will return directly and make it go through the networking stack. We have validated that this could also work, but it also has some potential problems. First is it looks too complicated because a single packet could appear at some devices more than once, and it may mess up the statistics of the network metrics. And but even it is more complicated and could reuse the work of we already have for open switch in open switch. It doesn't mean that this could have better performance, considering it also introduced some overhead when doing the redirection. and when processing the packets more than once in every device. So the last step is to route the traffic to user space. And so we also compare the iptable's net filter solution. The advantage of this mode is that iptable's net filter takes effect after layer 2, meaning that all packets received on all devices will go through the same net filter hook, and we don't have to do anything special to support applying net policies to multiple devices of a node. And and another advantage is that net filter is a mutual mechanism to do such job, and has already been used by some CNIs. And the only problems we can think of for iptables is that it's poor performance when there is a significant number of iptables rules. And but in this use case, applying net policies to node, we think that maybe that the expected number of net policies rules will not trigger the performance bottleneck of net filter, and therefore we did some performance evaluation, and sorry, let's compare this. Let's wrap up the comparison first, then I will share the numbers of iptable solution. The first is for OS, we can get maximum code reuse because the work is already done for pod. If we can get traffic into OpenWSwitch, they can be reused directly. But its disadvantage is hard to support multiple devices, and it must bridge network device, and hard to maintain compatibility, and could be error prone. TWPF eBPF is advantage is we can have full control on packets, but it also has the same problem to support multiple device, and it means everything needs to be developed from scratch, including a priority-based packet classifier and connection tracking. Because the priority-based packet classifier is because of the current model we used in Antrea policies. We are not simply whitelist firewall. We support prior-based, so it means a more complicated algorithm to support the classifier. And the third solution problem is also hard to support multiple device, and its data path is a little complicated and maybe hard to troubleshoot. And because the packet is processed more than once in multiple devices, there could be some uncertain side effect introduced by this. iptable's advantage is it's a mutual solution, and it could easy to support multi-device. The only problem is poor performance with significant loss. So we evaluated iptable's performance in this use case using iperf and netperf. As we can see, the bit rate representing the throughput of a connection is almost unaffected by the number of rules. This is expected because in stateful firewall implementation, we only expect the first packet of a connection could be processed by all rules. After the connection is accepted, the subsequent packets will be allowed directly. So regardless of the number of rules in IP tables, we don't expect it affect the throughput of a connection. And for the latency of a connection, the round trip latency, it's same because only the first packet could be processed by all rules. And as you can see, it's also unaffected by the number of rules. However, for TCP CRR, the capacity of processing new connections, it will be affected by the number of rules. As we can see, when there are 10 rules, and each rules referring to an IP set containing 20 IPs, it's almost unaffected. But when there are 50 rules and each rule referring to 100 IPs, the performance decrease about 9%. And when it comes to 100 rules, it decrease about 13%. But for this use case, I think in reality, we don't expect that there are too many rules could be applied to a single node. There could be many net policy rules in the whole cluster, but for a given nodes, the typical usage is that a user would by default deny all traffic and only allows the traffic that they expect to be allowed for some control plane communications, like the communication between Kubernetes components and between Antrea's components. So if we map one port to one IP table's rules, I think typically the number of rules that apply to a node would not exceed 50 rules. Yeah. So the performance degree should be acceptable in this case. And also, even there is a decrease in IP table solution, it doesn't mean that using other solutions would not have such decrease. For example, even we invent something new using TCP/eBPF, it doesn't mean that the packet classifier could be more efficient than the current IP tables classifier. Yeah, when supporting priority-based rules is a requirement. So, yeah, in this proposal, we tend to go with the IP tables approach because the advantage we have talked about and the minor decrease in this use case. And if there are no questions about the data plane, I will continue to introduce the proposal about API change and the control plane change. Okay, let's continue. For API change, because we want to use the same posture to support net policy applied to nodes, we consider making some change to cluster net policy because Kubernetes node is a cluster scope resource. So it's not reasonable to have Antrea namespace scoped net policy to have the ability to control the policy of nodes. so it will only be applicable to cluster policy. And for a cluster policy, previously we don't allow the use of node selector. Actually, for the data structure of apply tool, there is already a node selector, which is used when supporting node as the source or destination of a nail policy rule. But we didn't allow it to be a specified we didn't allow its node selector field to be specified for when it's used in apply tool. And in this proposal, we would like to make a change that when the apply tool of a nail policy or its rule is a node selector, it means the policy is applied to Kubernetes node instead of pod. And optionally, and also for simplicity, we don't allow a single apply tool to use node selector and pod selector together. This is to be easier to differentiate the data plane enforcer of a rule, because if it applies to node and pod at the same time, we will have to use two different reconciler to plot the same rule. So to keep this simpler, I wanted to introduce a limitation that we don't allow this use case. For example, this cluster policy would mean that user want to restrict the ingress traffic of all Kubernetes control plane nodes, and it will only allow this IP block and all nodes in this cluster to access their TCP 6443 port, and all other ingress traffic will be dropped. And for configuration change, to isolate the experimental code, we will introduce a new feature gate called the node nail policy to control whether the nail policy and will take effect and whether the code related to that feature will be wrong. To address one specific use case, we may also want to introduce a configuration about privileged rules. This is because unlike rules applied to pods, if nail policies applied to node is misconfigured, for example, if user configure default deny first, then they want to add some whitelist rules, it may cause problem because the realization of the denied default could block all communication between Kubernetes and the Antrea components. There will be no chance for Antrea to receive another set of rules which allows specific traffic, and this operation may be not revertible because user will also not be able to log in the node, making any change to the firewall. So to prevent that situation, we want to introduce a set of static rules configured in the configuration file, which will take priority over node policies. For example, we make them default to some whitelist port like SSH SSH port 22 and Kubernetes control plane API port 6443 and Antrea's control plane port, so that even the default deny rule is configured first, it will not prevent the connection being broken by the connection between control plane components being broken. And because they are not, they are configurable in configuration files, user could also configure them to be more suitable for their use case if the default one doesn't work for them. And the third configuration we need to add is an interface name option. It will determine which network interface node net policy will be applied to. By default, we could apply the node net policy to all interfaces of the node. However, user may want to only apply the policies to some specific port. So we have this configuration to allow users to specify the expression of the network devices they want to have network policy applied like this. It will apply to all devices with a prefix like this, and another device with the exact name. Next, let's get a quick look on how this would work. Like a typical net policy workflow, user will first create a cluster net policy which has a node selector in its applied to field. Then Antrea controller would convert the cluster policy to an internal net policy with applied to groups containing nodes, such as this. In important net policy case, the group members would be ports, and in node net policy case, it would be node names. Then in Antrea agent, if it says that the net policy rule applied to its nodes instead of ports, it will invoke another data plane interface to realize this net policy rule. For example, when we process a rule in the net policy controller of Antrea agent, we could check the type of target the rule is applied to, and if it's for nodes, we will have another reconciler, whose implementation is based on IP tables and IP set, and call it to realize this rule. And this port rule reconciler is the existing one based on OpenFlow, designed for port net policy. And we could still reuse the same interface we already have in net policy controller. The data structure of the rule could remain unchanged because the only thing changed for node net policy is that the target member of completed rule would be node instead of port. And we will have another implementation of this interface using IP tables and IP set. It will be responsible for realizing node net policy rules. And if the proposal is approved, we plan to target the next release 1.15, and currently Hongliang is working on the data plane support. He will create a he will create a new implementation of the reconciler interface, and using iptables and ipset. And for the other changes, Kuma will be will make some changes to the API and the workflow, how we distribute the node name policy, and how we compute the span of node name policy. Yeah. And if this proposal is proved to be working fine for Kubernetes node security, we could potentially unify the implementation of external node on Linux in longer term, so that we have a unified implementation regarding the security of node itself. And hence the problems we mentioned in the beginning could also be resolved or avoided. If there is, that's all from my side. And if there's any questions regarding the proposal, please let me know. And if not, Honglia could also share some detailed designs on the data plane work. Yes.
Thanks, Chandler. Do we have any question, any comment on the proposal? Yeah, go ahead.
So thanks for the great introduction, Chan. I have a question about the Windows implementation. By any chance, do we consider that to implement a firewall solution for Windows Node?
Yeah, we had some consideration how we it's kind of and more work than supporting node name policy on Linux, because it's not a the solution is not a very clean when we want to support both port name policy, port name policy and node name policy at the same time. Because I remember Wayne told me that to leverage the Windows native firewall mechanism, we will not attach the network device to OS, so that the Windows native mechanism could take effect. However, it will be conflicted with what we have support for port name policy. And given that Windows platform already attach the node name policy, attach the uplink device to OpenWSwitch in all cases, I think at the moment it may be not worth to using another way to support Windows node name policy. But perhaps we could still use the same way as external node feature. Yeah, based on the fact that the port has already been attached.
Understood.
Yeah.
Thanks.
Yeah, it's a little different from what we do with Linux. It's a totally new approach.
Okay.
So sorry, Chen. Maybe I want to add an additional question. So you mean that on Windows for the host network, we still attach the physical network adapter to OpenWSwitch, and we still follow the existing solutions to use OpenWSwitch to provide the host network policy. Then do you mean that we need to implement the new APIs existing which was trying to support host network policy on Windows in the next Antrea release?
I don't mean in this. It is in scope of this proposal. I just mean it seems the most feasible way at the moment, using the same mechanism to support a node net policy on Windows, right? But I didn't scope it in any release, and because we as far as I know, supporting node net policy on Linux is the only requirement we have received.
So you mean that the feature of hostnet policy is supposed to be supported only on Linux, at least in Antrea
Yeah,
1.15?
Yeah, in this proposal and in when I say its target is release 1.15, it means Linux platform support only.
Okay. Okay, I see. Thanks.
I just have a quick question as well. I mean, I feel like to be really honest, I feel like, keeping this and all the other stuff like in cluster network policy is actually feeling a little bit overloading cluster network policy to me, because as the example you presented, if we have a node selector for the apply to, it only makes sense, obviously for IP blocks and other node selectors, which we have in the ingress or egress peers. But does it actually make sense for something like I have a policy that I apply to node selector, blah, 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 and then in the ingress and egress, there are actually pods? Maybe it does not, right? So
that is case exists. I think, for example, when some components in Kubernetes is deployed in is deployed in non-host network pods, but they also need to access the Kubernetes control plane, for example, to access the API server to implement a operator, right? They will need to access this pod as well. So the selector could be a pod selector. Right?
Well,
is that
do
your
we
question?
do it the other way around today, though?
Sorry?
But do we do it the other way around though today? Like we apply a bunch of stuff to the pod and we have, allowing egress to no selector being the peer.
Yeah, that's one way. But that restricts the outgoing, but not the ingress of the node. And for every policy, it can actually be implemented using the two ways, right? We could restrict the source egress, and we also could restrict the destination's ingress. I think for some users, they may feel safer to guard on the ingress of the destination. But I yeah, of course there could be two ways. Yeah. And another common use case I think of is that for the egress of the cluster node policy, and when some applications are being deployed as host network pods, one use case I was aware of is for some users, they need to use host network port, and they want to customize the firewall of the node so that their port could communicate with specific destination. However, because of the hard-coded firewall rules of the Kubernetes distributions, they have no, they cannot make it work in a efficient way, and they will have to run some hack port to program the IP tables of the node to achieve it. And they also need to take care of some problems like the rules being reverted on restart or something like that.
Okay, I see.
Did I answer your question? You mean it's not? It seems not reasonable to have this in cluster policy. Is that what you mean?
Well, I'm not saying it's not reasonable. I just like you said, right? Like usually it doesn't make sense for apply to contain node selector and pod selector at the same time. Obviously, we have other like namespace selectors and bunch of other stuff in the Antrea quote unquote policy peer, right? So that to me feels like a signal that we probably would at some point try to chop stuff up, because we that right now we do this for regular pod to pod policy, and we also do cluster network policy for L7, and now we have the node policy, which is essentially solving a bunch of different use cases than the original policy, but all of those are kind of like in the same CRD. And then we have, really weird rules saying that you can't mix this and that together. So, that's something that I'm trying to think more about, and, at least try to make things a little bit cleaner so that, I don't know, people just don't accidentally shoot themselves in the foot, and we don't have tons of validations to do when people actually create a cluster network policy, in my opinion.
Yeah, my understanding is that this kind of unification is on purpose to on the purpose to make users use the same to configure their policies using the same posture regarding the scope of the policy and the target of the policy. If you remember, we also support the cluster policy across cluster set, right? And the only difference is that we could specify the scope of the port selector to be class set, and we also support apply to be a service selector. So to me, it's like the apply to could be many types. It could be port, could be service, it could be node, and it could be even be yeah, or maybe just three types. Yeah.
And thanks, Chan. Thanks, Yang. We still have a few minutes. Do we have more questions on this feature? And Chan, I have a very simple question. And probably you mentioned it, but I did not get it. In terms of traffic that this applies to, this applies only to node traffic, pure node traffic, and not on the traffic for pods that are running on that node, right?
Yeah, it's only for traffic directly coming from the node or directly towards the node. It
Yes.
doesn't include the forwarded traffic.
And sorry for this other number question, but does this exclude also the host network pods, or will the host network pods be captured by this policy?
It will be captured by the policy. This is because of the nature of the host network pod.
Yeah.
We cannot differentiate the traffics and by normal process or the process running in C group, right?
Yes, that's right. Okay, thanks. Sorry, that was just for my clarification. Thanks a lot. Okay, any other question for Chan? Because I believe that Hong Liang has a little presentation on the data path, right?
Yeah.
Okay, so maybe let's go to that because we only have a few minutes left into the time allocated for today.
Okay, I'll start my screen right now. Could you see my screen? Only a few pages.
Yes, we can.
Quick. Okay. I'll introduce the node network policy display demo. I only introduced the ingress rule because for the egress, they are almost the same. So for the ingress rule, we just modify the input chain. As we know, we have Antrea input chain, but finally I remember that it's in routable. This time we need add a custom chain called Antrea input chain in filter table. In this chain, we have another two rules. One rules whose target is the another customized chain called this Antrea policy ingress default. And this chain is to install the previous IP table entries mentioned by Chen, like allowing SSH or other services used by Kubernetes or Churn. Another chain is a chain to install the IP tables entries for ingress rule. Then in this chain we will have items IP table items for every rule. But as we know, some rule has more than one services. Maybe like a HTTPS or other services. In this case, we only match the IP from this here. We only match the from IP addresses, and its target is another chain, and this chain install the IP table entries for service of in ingress rule. And another case is that if the rule there's no service in this rule, just use the accept, reject, or drop directly. Of course, the accept is mirrored by allow in Antrea rules. Okay, this is the hierarchical of chains for ingress rule. For the egress rule, they're almost the same. But in egress rule, this is output, and this also output. But the name is almost the same. Okay, we just take a simple example for the implementation. We can see we have two ingress rules. For the first one is priority. Its tier priority is the same. another protein. This is 1, this is 2. We know in mature agent, every rule has an unique ID. It's in 16 bits. Here I just used this ID, but in real in real world it's not impossible. But we just use the here for simple. Assume that this rule ID is 16 1 and this rule ID is 16 2 tools. Okay, we have these two rules, and the IP table, the IP table, the corresponding IP table is like this. You know, we have these two chains, and this chain is to hold default rules, or pervasive rules. This one is to hold the ingress rules. In the default in this chain, we have some pervasive rules, like will allow the establish the connections, and this is also a simple example to allow SSH. You can. I'm sorry. I need to to a meeting room because just wait a few.
Hello, Chen. I have a question about the default rule. For example, the SSH port usually is 22, but it might be different port. Do we allow the user to specify the port?
Yes, it's in configuration file, so user has the ability to customize the default rules, which makes most sense for them. Yeah.
Okay. Okay.
Okay, I'm back right now. Okay, let's continue. We can see this rule. This for the first ingress rule. We may notice the target is a chain. This chain holds this service. Holds service with 2 TCP ports, and this is another rule for the second ingress rule. And this is the this is a chain to hold the service. And this rule is for the drop one, for the drop. And we may notice the IP side here. This IP side, the IP side host contains all the IP address to match the source. To match the source IPs for the ingress rule, we may see the name. We may see the rule. We can see how to generate the IPsec name. We have one prefix like this entry policy, and this is the rule ID. This is for IP protocol version. Currently, we use IPNet type IP site because we need to support IP blocks, and just like this, the IP block for IP, we will convert it into an IPNet like this. Assume that this is these are two node IPs. Currently, we have 4 categories rows. IPv4, IPv4 ingress and egress row, IPv6 ingress row and egress row. And for IPv4 rows, the ingress rows, each row will be calculated and restored to Antrea policy ingress rows. This chain, like this, every category has its own target chain, it will cast all the ingress row or egress row. It will be organized in a linked list. When adding or deleting a row, the agent will calculate all the IP tables entries in the target chain and restore it with no flash. With no flash, it can only install. It can only but it can only affect its own target chain, will not affect other chain. Like for example, we only add an ingress row for IPv6. For IPv6, it won't affect this chain, only affect this chain. For how to organize these rows, I have a simple example. When we want to add a row, this is just for simple. It's not in real world. It should be the 16 bits row ID, and this the row. The priority is not only an integer. It's a structure. It's structure. And we just use the simple. Just use this for simple. Okay. If you want to add an ID, add a row whose ID is this, then it will be inserted to the cache, and then from the cache, then Antrea agent or the reconcile interface will calculate all the IP table entries and restore it to the target chain. Besides, its corresponding IP set will be also created. Another example is that to remove a row like this, then the reconcile interface will also calculate with the existing cache and restore it to the IP tables. At the same time, its corresponding IP set will be also removed or destroyed. Another one more thing is that for updating a row, as we know, these fields or attributes, when we updated any of these attributes or fields, the row ID will be changed. It's like it's like that we install a new row, not updating the existing one. But one more thing, if we use group, we only update the members of a group, not update the attributes or fields in the network policy. We will only update the corresponding IP set, not update the target chain. Okay, that's the implementation demo currently. In next release, we don't support layer 7 or IPQDN currently. Okay. No, any question?
Not from me. Not sure if anybody else here has a question for Liang. Waiting a few more seconds. All right, so it seems that's all for today. So I look forward to see the PRs for supporting this in review for Antrea 115. And I would like to thank Chan and On Liang for these presentations. And yeah, that will be all for today, unless anybody has some other topic to bring up for today. Going 3, 2, 1, 0. So it seems that it'll be really all for today. So thanks again to Chuan and On Liang, and see you in 2 weeks' time. Thanks, and have a great one.
Thank you. Bye.
Thank you.
Thank you.
Bye-bye.
Bye.